has a strong technical intelligence and geospatial
artificial intelligence as used in advanced agriculture research. Where I am now. Okay. So the machine learning is a software artificial intelligence. So that has been widely used in research and industry. So most of them know what is the difference between the human and machine. So we human learn from the experience and machine need to be told what to do. So can you get machine learn from the experience? So answer is yes. So this is the precisely machine learning. So we are now generating vast amount of data that make agriculture research and farming increasingly data driven, and it will be the data driven in the futures. So most important application of machine learning currently used is disease identification and forecasting, yield prediction, and some cases fertilizer recommendation. Another important application is machine learning, weather-related risk analysis and forecasting. This is just one and most important is the using machine learning by throughput of DNA sequencing and genomics prediction and phenotyping.
machine learning people are facing now. We have a lot of feature, but limited number of sample. How to apply machine learning to select the optimal number of feature and get the better prediction. So this method we try, this approach we try in Bangladesh. We apply stack assemble feature selection on general machine learning, and then we use this method to predicting wheat hill in Bangladesh. So before going to do, I just give a brief introduction what stack assemble model is. Stack assemble model is nothing. It is a combination of different machine learning models. So you know the most of the machine learning, most popular machine learning, RF, random forest and boosting the GBM are assemble model. But they use similar model, not diverse model. Stack assemble use different kind of model, then stack them, then do the prediction. It's mostly the cross validation, the stacking. So this is the two-level approaches. Model one is a base learner. We train the base learner, and then we get the prediction from base learner. Use this prediction to develop another model, and use it a meta learner or simple meta learner here. It's a level 2 model. So this is the sampling site I used. Only 800 wheat crop cut we did in 3 districts of Bangladesh. This is a non-traditional wheat growing region in Bangladesh. So we collected a lot of data during the wheat cultivation and also did some survey to get the information of previous rice crop. And we sampled the soil and analyzed them, and also gathered the weather data from European Meteorological Association and processed them. And we use the 7 model for machine learning, most popular model. And we just stack them. And for feature selection, because this model has a very limited number, when we run the model, we get the feature, we get very unstable feature selection. For this reason, we run the model 100 times. And we get the weighted average of the lowest error component. We weighted average the mean squared error and rank the variable. All variable, we rank them first time. This is the variable used. And then we run the stack assemble model with different combination of the feature. We found that feature with wheat maturity date, ground cover, weeding, application of boron, and rice harvest date, and soil pH applied has the lowest RMSE. So then he decided this feature might be the good feature to selecting to develop the model and do the prediction. So we tried again with 4 models. We found the stack assemble model has the highest R squared with lowest RMSE. We get a lot of improvement for other methods. This is the feature. Then, because a stack assemble model is very difficult to identify the feature importance, not like random forest. And all of the components, stack assemble model have a different feature selection approach. So here we apply model agnostic approach to select the feature. Is called the permutation with feature selection. Then we found the with maturity date, ground cover, most important factors. And these are, then we apply partiality dependency plot, see their response is either is positive or negative way. So similar approach we apply the 2 data set in Bangladesh and Ethiopia. This is called NOPT, Need to Know Mission Project Trial for the maize. So this is the collaboration of work with Ethiopia, CIMMYT, and when I was in Bangladesh, for Bangladesh CIMMYT. So we apply similar approach, stack assemble machine learning with NOPT data, and with large number of secondary variables generated from the soil, train whether it will be global soil moisture data, and remote sensing based MODIS, NDVI, and EVI. And we predict 2 variables for maize yield under Newton optimum condition and Newton limited condition. That is, limited condition mean yield without N, without P, without K, without NPK, and also agronomic use efficiency. Then you calculate the Newton requirement. If you do variable, you know that equal response and agronomic efficiency is easily calculated requirement, then we predict whole cropland of Ethiopia and Bangladesh. And then you do some economic analysis. This is the model performance of the model. Again, stochastic performs better than all other model. This is the output for Ethiopia. So this is the left-hand side show the predicted yield and agronomic requirement and economic return. And this is the output for Bangladesh. So this is the map. So we are still working with published these things. So this study I was working with Cornell University with collaboration work with to find out the spatial pattern within field variable silage yield. And this is important for optimized resource allocation. That's mean to apply variable rate of fertilizer application. So we use a large number of high resolution yield data. We get the data from the John Deere, and they collected the data every 1 meter interval when they harvest the wheat with the combined harvester. This is the data is 2005 to 2018. So we use this data set, and also it's combined with high resolution remote sensing data. We get the data from the planet. So we get the two variable here in VDI and EVI. So we only use the 2018 data. I'll show you data. Other data is still there's a problem with the high number of cloud coverage, because in the summer in upstate New York, it's the main problem. It's very hard to get the image without clouds. So there another variable generated from this remote sensor, this data set is called the green ground cover. This is very important variable. It performs better than NVDI. Actually, this is the calculate from the based on the soil, bare soil line, and also an perpendicular vegetation index. This is the complex equation developed by some Stephen Maas in Colorado University. He is retired already. So use this formula and develop and create a map of ground cover 2018 or for 12 days. 12 days intervals in from June to September. So, and then we did a simple correlation study, find out which date is highly correlated with silage yield. We found this is only from June to July, middle of the July has some strong correlation with yield. Both ground cover NVDA has a similar relationship, and EVI shows some little bit difference. And when maize plant are going to maturity, the relationship decreasing. So then we use an automated machine learning algorithm. This model developed by S2 for R and Python. The automated train and cross-validate a variety of algorithms. So including generalized linear model, random forest, extremely randomized trees, gradient boosted machine, and deep neural network. So during the training process, both PSPCI random source hyperparameter utilized to generate the models. So number of models depend on the hyperparameters and scoping metrics. So when model are trained, at the end, they develop two stack model. One, they select the best model from each family and then stack them, and then stack all the model, and then give you a leaderboard analysis to show you which model perform better for prediction in cross-validation state. We can add here another data set as a validation. Here I use not dependent cross-validation. I forget to mention here that I split the data in 3 parts here for training, validation, and testing. for model development, I use the training and validation data. So they compare the validation, rank the model according to the performance of validation data set here. So this is the performance metrics. We see the stack assembled model. Stack with all model perform better than all other model. It has the lowest RMSE slightly, then stack the best family. So and then we tested the total independent training data set. We found the model perform little bit well. Not there is some only 50% variability they explained for unknown data. So another important thing. So when you do the permit feature important, we found so another variable include here. We collected the DM data, very 3-meter DM data of this field. We used the DM elevation for the model. We found the DM is the most important way coming out. A reason why we find out that this soil has a lot of, this field has some low space, and this yield is the low-lying space is as a lower yield due to the water accumulation and other things. So the DM is coming is the most important variable here, and also all of the variable in the NVDI in June, especially the month of the June, contributed more in prediction of the wheat yield. So this is the still ongoing work. We have to do some 5 sites, then we'll make conclusion to do some of the suggestion of the farmer for their variable rate management. So I told you that machine learning has another important application is the digital soil mapping. So people are using very largely digital soil. Before that, digital model largely use geostatistical model. Now they apply machine learning for the mapping. So this study I did with collaboration USGS. So we applied to map soil carbon vulnerability in 4 states of USA in Midwest, Colorado, Kansas, and Wyoming and New Mexico. So we get the data very high pyrogenic and particulate carbon. Pyrogenic is called the so-called black carbon, is highly resistant carbon, and particulate highly vulnerable carbon. So then use this to mapping the soil vulnerability map in Western USA. So here we apply 2 methods together. So we apply machine learning and geostatistics together and make the prediction. So use the large number of environmental data, and this is the soil sampling location. And then this is the environmental data used for this mapping, and then get the final prediction map. We use a lot of statistics to get the best model. So machine learning is largely another application, a remote sensing application. We know everybody that remote sensing is applied crop identification, feature detection, and yield prediction. People largely with machine learning in remote sensing data. Most common method used before the support vector machine, random forest, they use, and then come the deep neural network. They use machine learning. And recently, the most common use for machine learning, so like on as like computer vision, something is called convolutional neural network to show the very high performance and high generalization for remote sensing applications. So here I saw some of the study, how I gradually go from simple model to the very complex model for its remote sensing application. This is a study I did with a collaboration with some student in Bangladesh. So the study is very unique. So we use from Landsat image from 1970 to 2016, from Landsat 1 to Landsat 8 to identify the river morphology and a change in delta in Bangladesh. You know the delta is very dynamic in lower Bangladesh in south. So land is forming and losing and every year. So he's a master student. He did a very great job. So he applied the very simple model, random forest, and identified the land where we are we get the loss and gain land, and those are land are stable for agriculture purpose. So after that, I just started to learn how to apply deep learning in predicting detect land use classification. This is the not agriculture related, this is urban knowledge, but methodology can apply in agriculture, any domain. So here I did 3 data set here. So mostly the optical and synthetic aperture or LiDAR data. So optical data I use for Sentinel-2, synthetic aperture Sentinel LiDAR data I get from New York State Environmental Agency. They had high resolution LiDAR data for a state. So for sample, we use for university campus to see how this model work for diverse environments. So we this is the study area. We develop a monitor training data set. And this is, although I do use the deep learning, but this is a very simple method I developed. It's a pixel-based classification. From the object, you convert to the pixel. Then you develop machine learning apply. This is the input variable, like raster stack I use. So there is a lot of variable in Sentinel and PCA1. So we develop some of the feature engineering, the texture of these variables. So then we apply the principal component analysis to find out the most important feature, the score that contribute more in all of the variable band. So then we have developed machine learning models. So this is our log loss for deep learning and in our accuracy. So we have a total accuracy very low, but even we can distinguish the parking lot and parking building and pavement, because we applied the DM data. We applied DM data easily distinguished the parking lot and the buildings. Both are the same signature in the spectral signature, like both are concrete, so they can distinguish the building or parking. So it is a final model. So one important contribution this study, I posted everything in my GitHub account. This is the very, very popular method. Those are not computer scientists, they're the domain expert. They don't know the special code to writing complex code runtime analysis. This is a very simple model. I have the same, I wrote these things in R and Python. It's a very popular, people are using this thing. Very simple way, no need to learn very high-tech computer coding and other things. So I think this works well. So then we are trying to develop some of the very advanced method for remote sensing data. So this called everybody the computer vision approach. Thus, this method is easily used in self-driving car to identify the object. So this is one of my students in UB, and this is the collaborative work with CIMMYT. A data set we generated when CIMMYT is with funding of the Gates in some area in Bangladesh. So then we applied these several 4 very high-tech computer vision algorithm. This is a dense computation network at UNET. UNET usually use a medical image identification segment. So we use the digital globe data from southern part of Bangladesh. This is a very complex agriculture. Even in the naked eye, you cannot see the boundary. So this digitization done by CIMMYT, on-screen digitization, and develop the training data. Then we apply this model and with other traditional edge detection model to see how this FCNN model, the FCNN mean full functional convolutional neural network, fully connected, sorry. So this is our ROC curve to find out the field boundary. We succeeded at about more than 90% accuracy. It can detect the boundary of this set of images. So as I told you that before, all of the machine learning we work, most of the machine learning our prediction is globally, not locally. So like the traditional geographical model we apply. So if you know our spatial location, so they can generate the coefficient for every location. not like linear model. So this concept now is start used in the machine learning. Most common use a geographical weighted model. So this only one thing, so we can use a special weighted matrix, and we have to plug this weighted matrix in your machine learning algorithm. So then we can get the feature importance in every location. This feature importance is calculated mean decrease like simple. Suppose if you use this weight matrix in random forest model, so random forest feature indicates the mean square error, decrease in square error. So there you will calculate mean decrease square error in every location. So if you have in your predictor. So the same concept they use. So only this weighted model available for random forest now. People are working to develop the ML model for other algorithm. I don't know how far they are now. So use this model on data set. So we are trying, one of my student here, she tried to predict type 2 diabetes in USA using the lifestyle factor and some of the education and social environmental factors. So education and poverty and other socioeconomic factors. So this is the county level data, 3,800 county in USA. So you did the 5-year average data. So she developed a model and we develop more, and then you do some different types of geographical weighted model, and also the use the geographical weighted random forest model, and compare for the non-spatial model too. So this is the feature importance in the global scale, global model. So we find the physical inactivity, obesity, poverty are 3 important factors contribute to type 2 diabetes. But this factor in contribution is very especially for large scale. So we can see that some obesity contribute most in western part of the country, and some of there's a highly specialty dependence. The reason why this is important. So if you do the management intervention, so which part we have to approach different way. So that means we have to go for the site-specific management intervention, not for based on global interpretation. We have to go to local level interpretation. So this study, I have not applied any agriculture data yet. And maybe in future, if you have a good data set, we need a very special organized data set to apply for this approach. So alternative geographical weighted model, very recently, there is another method, interpreted machine learning in local scale. We know that most of the machine learning is considered as a black box. It's very hard to explain. More accurate model are very high to interpret. More simple model is very high, very easy to interpret, like simple linear model regression. But their accuracy is not good at more highly complex models. So this Blacksburg machine learning model currently being used in high-stake decision making by tech giants like Google, Facebook, and Amazon, targeting the population using the social media bots. This is the very important topics now, and now USA is a Congress everywhere people are discussing these things. There's a software that application that run automated tasks over the internet. That means all of the social media, especially Facebook, they're targeting the people using the social media bot. So if I live in South, if I search in Google the climate change, maybe I can find out all of the page coming out the climate change as a hoax. Something like that. If you are in the north, I search the climate change in Google, I will get climate change has some negative page, all of the page. Because this social media bot automatically detect my location and try to predict my intention, or what I believe or something. If I am liberal, I will get something related to the liberal. If I am conservative, I will get something to conservative mentality. Because this model, Blacksburg model, has not released yet. how they did this. But some of the scientists, especially open source forum, they develop some of the, they just develop some of the method, and this method is available now. So this is called explainability or interpretability of model. So there has two types. They apply any, you can apply any machine learning model. So this is on kind of model agnostic, that is extract post hoc explanation by targeting original model. We have to apply after fitting the model, we have to apply a post hoc model. And this is called sometimes called model explainer. So once you develop the model explainer, we can apply this explainer in feature important or partial dependency plot and others. And also this model has can apply two kind of interpretation. Personalized interpretation is a local interpretability, similar like geographical weighted model. And at the population level, it's a global interpretation, something like the traditional ML model. So you can apply these things. So this approach I first time apply in an data set in lung cancer model, mortality rate prediction in USA, and see the how the risk factor contribution varies, especially in space. So this paper is under in final stage for publication, under review now. So use the very large number of data and apply several recent approach of machine learning in this work. So we apply something is called partial dependency plot or another approach. I will discuss later when I discuss these things in agriculture data sets. And also the bivariate partial bivariate PDP. So with the two factors, if are highly correlated, there is an interaction. And also this is the map showing the additive contribution of the risk factor in lung cancer prediction, similar like feature importance. So we calculate this additive contribution for each risk factor for each county and mapped in, and you can easily visualize the contribution of smoking. Where is the smoking contribution is higher for lung cancer, and where the poverty has more contribute to lung cancer, where is the elevation has some contribution of lung cancer. You can easily visualize these things. I think this is the first kind of study yet for this kind of large data set for explaining the local contribution of prediction. So this approach, I applied two data sets with collaboration with CIMMYT, with on two, both are the survey data set, how we can predict in self-reported crop yield from the survey data. So here we apply automated machine learning, explainable AI. So this is the data set, a free data set. So there's a household survey data set. They collected from several locations in Bangladesh in all of the large number of data sets. After clean up data, so we use, we also develop some of the secondary variable this data set, some of the remote sensing data, some MODIS and VDI, and also some of the weather data for each location, rainfall, temperatures. And also we gathered some of the data soil database from national soil database for all of the soil variable for each location. Then we, this is the methodology we developed. So we split the data from the data frame, is a training and test data set, that apply the training auto ML. And we select the best model with the CV matrix in the CV cross-validation matrix, and then use the best model for prediction for develop explainer to explain the model prediction outcome. This is the performance of all models. We found only this is the fourth cross. I forget to mention. We developed model for the outrise. The outrise is the range. It's a rise from the transition period in between summer and winter. The almond rice is the rain-fed rice for the summer. The boro rice is a dry season rice, mostly irrigated, and wheat crops. This is the wheat crops. We developed the crop-specific model. We mostly found this only owl rice, except owl rice, when the stack is assembled with all model. And for the wheat, the best of the families found performing better performance in cross-validation stages. So then we test the model with independent test data set. We get the very good prediction. It's not bad. I did not expect this kind of prediction for the survey data. So we can predict very confidently the self-reported yield of the farmers. So reason why it is important, because once you have the model, so we can reduce the survey time, this kind of a study. So the implication of the study, once we have trained the model, then he have a super limited number of, we can go for the limited or the targeted sample for the survey to predict the yield. This is the feature importance for the permutation base. Only the outsize we can find out the crop types is a very important factor, because this is a hybrid and local, and farmers is hybrid, local, and HIV rice. And other three factors, fertilizer rain, obviously, is the most contributing factor yield. And for the boro rice, secondary growth duration, highly, the growth with high variety with longer growth duration is contribute to more yield. And wheat, we get fertilizer and another things, elevation. If you grow is little bit flat-free zone, we expect the higher yield in wheat. This is the yield difference north and south in Bangladesh. So the partial dependency, just a term here, I'd like to say something about the partial dependency plot and local and accumulated local profile. This is a two new concept people are using now, local dependency or accumulated local profile with partial dependency. Why they're using this? Because when you develop partiality dependency plot, is actually when your predictors are correlated, is sometimes you'll misinterpret the partial dependency plot. So it is better to use accumulated local profile. So people are starting, if you see that there's a two factors, a partial accumulative run together, you see that your factor is not expected to too much have as some not interrelated. No, interrelated. So you can make some conclusion that our partial dependency plot may be good enough to explain the expected yield response in respect of nitrogen rate here. So I don't go to the details here. So once we do that, then we have another question come out. So how your variable is interact each other. We can easily calculate for interaction extent of each variable for model outcome. So it's called the H statistics. So it measures how much is the variation of predicted outcome depend on interaction of the other variables. So once you say the H statistics actually vary 0 to 1. If you have a 1, then we can conclude that this very highly interaction is very high, this variable with other variables. So if you see the interaction is there's not interact. So you see that the crop variety, fertilizer, and farm size highly interact value. So we can do calculate easily for pairized interaction. So I have not showed the data is highly computational expensive. I studied last night, my computer is stuck, then I give up. So you can easily calculate the pairized interaction. It's a crop variety for fertilizer N or something like that. Yeah. So another important aspect, I told you, I apply the local importance in stack sample model, something like a local contribution of prediction. It's called the model agnostic data explanation model prediction. It's a very long word. simply people are using the breakdown plot. So this breakdown, we break down the variable contribution to visualize and describe how feature contribute to prediction locally. The main goal of this approach to decompose model prediction into parts that can be contributed to particular variable. So we decompose the model prediction into contribution for in survey location in this study, attributed to different explanatory variable, then calculate average for each moja. If people know from Bangladesh what is moja mean. So this is the land administratory boundary for Bangladesh. So we collect a survey, every sample is collected, on sample, there is on moja, there is several samples. So we calculate average value of prediction for moja and mapped it. So here I show this how we get from variable importance. We found the crop variety for Aush is a very important factor. So when we do the variable contribution, this is the first important variable I mapped. Where is the location of the where variable ranked 1? Suppose, just to explain a little bit a better way. So crop variety, we found number 1 in 37 moja in for Aush rice. And you know the farmers start using supplementary irrigation for crop yield. Although the Aush is considered as a rain-fed, farmers apply the, if he apply the expect a lower yield, they apply the 12 location, supplementary become ranked 1. Fertilizer at 8, soil P8 location. For almond rice, crop variety, that is types of varieties, we found 87 location is ranked 1. Fertilizer 33, supplementary 21. For Boro, fertilizer and 32. The reason I show this data set. So if you go to the global model, we have an onset of pictures. We see the crop variety universally, I mean, the main of the data set, but actually when we decompose our prediction with variable attribution, we found the different picture a little bit. So variable ranking is different for location to location. So for site acquisition management, we have to think about where we'll go. Sometimes we can think some of the area, we can say, no, this area is people already apply the crop variety is high, maybe you'll contribute, maybe you'll go for the fertilizer nitrogen with combination of the crop variety, maybe you'll get the variety, the higher yield, or some other factor maybe influence, we don't know. Some of the variable coming out only the some things, other factor it did not show here, there's other variable important here. So is this called this kind of in-depth analysis for management intervention, something so in local level? So another approach we apply to collaboration of CIMMYT, this is the defined data from the Nepal. So this is the survey data. So they collected large number of survey to identify the household, those are food secure or not. The simple data set, they ask for the food sufficient and inadequate. This is the not regression model, this is the classification models to try to predict something binary classification. There's a lot of data set here. It's not a lot, but this is the data set they collected. Year, age, and household size, rain-fed, irrigation types, livestock number, and gender of household, head of the household, and their remittance income, and the caste, either the lower or higher caste, and other data sets that they developed. I get this from the CIMMYT, the infrastructure index, it is the principal component by indexing. So they just measured the distance from one-way distance from 11 facility and do the principal control and develop 0 to 1 index, and also the region where the data are from, livelihood mean, they are agriculture dependent or non-agriculture dependent. So we use the similar approach and apply AutoML and develop the prediction model. So this is the high accuracy. So it looks surprising. We can predict very high accurately the household food security level, more than 90% accuracy. So we found the stack assemble model is the best, has the highest accuracy. And we also test our model with total independent data set. It's out of bad data sets. We did not include this data set in training the model. So we get the similar result. The stack assembled model accuracy about 86%, and a very low log loss is 0.32. So then we apply the explainer and calculate the permutation by feature importance. So we found that infrastructure is the most important, and schooling year and age and most important, and number of livestock also has some contribution of food security. And this is then we develop partial dependency plot. You have to be very careful to explain this data set partially. It's not like a linear model. This is a classification model. So this is the x-axis mean the average probability of prediction of food insecure household. That's mean. So if you have this is our complex relation infrastructure. I go for the schooling year. So if you have a high schooling year, so you have likely to have a probability of food security is very low. So model is totally a different way. You have to explain here. So then we decompose our data in the male and female, and we use the same model, but explainer we develop for male and female model to find out which factor influence the male domain household and female domain. It's almost similar, just ranking is different. It's a female domain household we found is very important factor. Second is the remittance. This looks like all of the females household, that husband working in somehow in Middle East, they get the money from there. There's that contribution of food security. So there is the most insecure people family who get the more remittance, and it's mostly happen in the female leaded household. And also we try to what is the important factor? Lower caste. We get the similar things in the lower caste families of the global data set, and also try to see how it is affect those are agriculture dependent family. Almost similar response, little bit change in ranking. So another strategy I'm working with is something time series prediction. You know, the machine learning is capable to predict a time series data and forecasting, especially weather data and price prediction is most popular now. Just to do some simple study to apply LSTM to global commodity price forecastings. Just with a simple result I'd like to show, because most of the price forecasting people use, this is the commodity price. It's not to a country level, a commodity price in the stock market. So all important factors here influence the stock market prediction is called VIX index. This calls instability social market. It's released daily on data set from market volatile index. It is we use this data set with monthly stock price, something wheat, rice, crude, and fertilizer and phosphate, and develop LSTM model 2019 to 2002. I see how they can forecast ahead 3 months ahead what would be the rice and wheat and maize price in stock market. Just do some of the try. This is not a lot of people did these things, but our main objective is to try to develop some other various advanced model here to see price prediction. With the first one is called the transformer model. So this is a very recently developed model, and try to compare. Our prediction is not bad. We did very nicely, very low forecasting is we can forecast a very low $4 difference between actual price and forecast price, and wheat $10 and maize is $4. So we are still working on some large data set and apply different methods, see which method is Well, the reason why we are planning to do this is similar approaches we have developed for weather forecasting, especially for Bangladesh. And one of my students is willing to work with me to develop very high and also to develop some of the very large data set in Bangladesh in groundwater data to forecast the groundwater depletion in a spatial scale. So this is the initial work we are trying to develop, and let's see. Today, I'd like to discuss another very important, very promising deep learning network. Here is called graph neural network. So now everything in the nature looks like a graph. These are all are interconnected. So this is that is a graph data universally language and describe the complex. A graph is collection node and interconnect with edge. Most of the social network we are connected each other, and we go to the traffic. Everything is each other connected. One node is connected to others. So people are trying to develop how to predict the node behavior using the study, the A's and others. So the reason the graph neural network is, so we applied it, one of my students is the chemical properties, how to apply the graph neural network for chemical properties prediction. This mostly this study, this graph neural studies social networking and traffic pattern, and also use the chemical data, and maybe future you can use the digital soil mapping because all of the sampling location is interconnected and there's a similarity with the neighbor character point. So if you develop, able to develop the network within the soil sampling location, easily can apply this network for prediction and develop digital soil mapping. So he's also working with that. We have not to do some yet any result coming out, but this result is chemical properties prediction is already, he did some initial analysis. Actually, he used the most famous EPA data. EPA, Environmental Protection Agency, they developed a online app. It's called Opera. So they have once you chemical structure, converted the smile, that's mean is a text format, and put this smile data in the app, you can easily, they will predict your chemical properties and what kind of chemical is. And they use mostly, this is the KNN-based model. So he used the smile, their database, and developed a graph isomorphic network. This is the graph-based network, and try to compare his prediction with EPA prediction. So he found a computationally EPA data KNN model. So before you need a lot of pre-processing to feed the model, but graph isomorphic network easily identify the, if you, no need to do pre-processing, easily find the identify the node behavior. If you feed the node, there's suppose a carbon, you know the carbon properties. In my training set, how carbon is connected to the another bond of oxygen is single bond or double bond or some is a free. If this information, a machine can detect these things, then easily can predict what kind of molecule this is. And this is very simple method. He get a very promising results. So he compared the EPA method. His accuracy is very relatively high, and it takes less time. So he's still working, and maybe he'll finish this analysis. Let's see. So and maybe we can apply these things in other aspects, especially remote sensing data. So if you consider if pixel as a node and each pixel correspond as a vertex, then you can apply the same approach in remote sensing object detection, also the digital mapping. So he tried one of my data set, is my PhD data set I use in arsenic sampling. So he almost developed the network now. So the most important part, he developed the network. Now he has to develop the modeling aspect. So that's all. There's too much talk. Any question?
Thank you so much. Thank you so much. A lot of questions in the chat box. we are going to cover one or two, and if you don't mind, I will send them to you so you can respond,
Okay.
and then we can publish them at the intranet.
Okay, sure.
Some of our colleagues are joining to other tasks. However, there is one question here from Juan Burgueño. It says, most machine learning methods are focused on prediction and the models are good predictive models, but usually does not consider the effect on the response. Parameters are not easy to interpret. Considering this, how helpful are machine learning models to identify biological relationships?
So far I understand that means it says biological. Can you make some clear what does it mean, the biological relationship? That's the actual relationship in real world, does it mean?
Juan Burgueño, would you please clarify that question, if you are still around? Maybe he has already gone. Okay, don't worry.
Okay, so actually, this is the, for this reason, all of the machine learning previously called as a black box. It's very hard to explain their interpretation. Now the blocks ball, they open the blocks ball like a white box. So if you apply some of the model agnostic method as a post-hoc method, we can explain any model like a linear model. So maybe we can interpret, if you know the domain, actually the main important things, machine learning people, very, very few people, domain expert are machine learning people. We have to have good idea about the data, how data works in real world. It's not like a cats and dog. We are identify that whether it's cats and not. If you want to apply the machine learning in environmental agriculture health application, you have to have good knowledge in the domain. You have to know what is the feature influence in yield prediction. If you find something totally different, I recently reviewed a paper. One guy tried to predict COVID, uses the flood map. I don't understand why he used the flood map to the flooding map in the COVID, because this guy is a computer science student. He has no idea what is the feature has a real world influence in your prediction. We have to be careful to select the feature. It has a real impact to your prediction in the outcome. He's right, yeah. So you have to, the biological relation need to be considered before the feature selection. Not select any feature, they have a no contribution like before that, all of the digital soil mapping, you see the history analysis. I not criticize their approach. They dump hundreds of variables in soil prediction. Most of the variable prediction have a no influence in the soil chemical properties. If you know the soil little bit, we can why just use this variable. They have a net distance from the road. They use these things in digital soil mapping. How come they use this thing? How come this affecting your soil properties, organic carbon? They have no explanation here. They publish the paper, no explanation, nothing. Why they say blah, blah. They dump the variable, hundreds of variables, then prediction. As a domain expert, we cannot do this. We have to understand the variable important, what variable is selected in your model. So, okay. So any other? So I have not seen the question.
Yes, thank you so much.
Okay.
Yes. Yes, we can, as I said, I will share the questions with you, and then if you please kindly respond to them, then we can publish them at the intranet.
Okay, sure.
For reference of our scientists. Just one, we can cover one more question, and then from Carlo Montes is, do you see any advantage of machine learning models over mechanistic models to predict yields, for example?
Yeah, actually, I have not tried these things yet. Some of the publication I see, they compare the machine learning and mechanistic model. Both have advantages and limitation. So all of the mechanistic that we said and have seen, somehow they use the physiological parameters to predicting yield. Machine learning does not take care. If the data is available, it's okay, it does not care. This is the biophysical factor they use, and also the learn from the back, the machine, they teach the machine. So some of the recent advances I see, they apply both together and they get the better prediction. And main problem is the physiological, the mechanistic, this kind of crop growth model. We need a lot of data to calibrate your model, physiological model. It's very hard to collect. You need an experiment setup. You need a lot of money to do that. And machine learning is a little bit advanced this state. We don't need this kind of physiological. We have a weather variable. We know the soil variable. We have a time series data. We may easily guess something what will be happen in the future yield. Little bit close to the future. Not perfect, but it's not bad with little investment. This is the advantage I think the machine learning has for yield prediction.
Thank you so much. Okay, so I would like to say thank you very much for your very beautiful presentation, very educative. We had more than 90 people joined in the conference. However, some of them have to leave because of other duties. So I would like to thank Dr. Zia Uddin Ahmed, Research Associate Professor of the Research and Education in Energy, Environment, and Water, Renew Institute, University at Buffalo, for this seminar that was presented today, Machine Learning and Artificial Intelligence Application in Advancing Agricultural Research. So thank you very much, Dr. Zia Uddin Ahmed. Thank you very much for your time, and thank you very much for the audience of being joining today. So if you have any final message, please go ahead.
Okay, so how to get this thing chart? Can I download this thing?
Oh yes, I will be sharing that one with you.
Okay, sure, it will be great. Yeah,
I will be sending this to you by email, and then you will kindly respond to these questions, very interesting questions, and probably you could also continue with discussion with the scientists as well. Okay, so thank you so much. Thank you very much.
Thank you, everybody.